Okay. So this chapter will cover everything whatever we studied in linear motion. We studied force. We studied velocity. We studied displacement. Right? So what is,
Yes, sir.
let's talk about each word, each term first. Let's start with the basic term. First, what is distance? Let's take displacement. What is displacement?
The shortest part to go from A to B. Yes, sir.
Yeah, shortest path. Displacement is shortest path. Now, what is velocity then?
It's the speed of the part. Yeah. It's meter by second, sir. It's the distance. It's a ratio of distance by time.
Okay, ratio of displacement
by time.
to the time.
Yeah, that's velocity.
That's velocity. What's the difference between this velocity and speed?
Velocity shows the displacement. Velocity shows the speed for the shortest path, sir. Whereas, okay, actually, speed is a scalar vector quantity and velocity is a vector quantity. That's the difference.
Yeah, I think you want to say so many things, but you got confused in saying one term, right?
Yes, I wanted to one at a time.
Okay, fine. Just let me activate the end. Fine. Yeah, as you said, it's a vector quantity, it's a scalar quantity. Fine. Now, what else?
Speed is distance by time.
Speed is distance
Total
by
distance.
time.
Yeah.
It's total distance. So displacement is the shortest part.
Shortest
total
path. This is the
distance.
shortest path. This is total distance by total time.
taken, yes, sir.
Yeah.
Okay, when can we say speed and velocity are same? In 9th standard, you studied both, right? Like in that standard, you were talking about like speed, velocity. Whenever you're taking numericals, whenever you're solving numericals, you will take same, both as same. But why? What is the reason for that?
Because it only has one direction. Sir.
Yes. It is linear motion. That's why we studied
Exactly.
in
Straight line, sir.
Yeah, linear motion. Here we are not talking about linear motion. Name itself suggests system of particle and rotational motion. Right? So I'm just giving you all basic idea about what is system of particle and what is rotational motion. System means like right now I'm sitting, so I'm object. Now my surrounding is like my walls, right? So whole like my walls and me together makes system. So system of particles. So I can be bigger particle, or there can be ant as a particle. There can be a atom is also particle. Anything can be a particle, smallest thing. So I think so. One more person join, Shrikar.
Yeah.
Yeah, am I pronouncing correct, right?
Sir, I didn't get you.
Yes, sir.
Okay. Yeah, I was saying like, is my pronunciation correct?
Yes, sir, it is correct indeed.
Okay. Because some students I find like they are very peculiar about their name. I want my name to be pronounced this way only. Okay. Fine. So that was about, yeah, force. Force was mass into acceleration. Mass into acceleration. So this is whatever we studied here. It is about linear motion. But here rotational motion, we will use same thing, but in different way. We will add angle here, angular displacement, angular velocity, angular force. So it will be torque.
Yes, sir.
Same thing we'll discuss in different way. Okay, so let's start with our chapter, system of particle. So first of all, let's know about body, rigid body. What is rigid body? What do you mean by rigid? Something is rigid.
It is very strong, sir.
Strong. Definite.
Yes,
Or-
sir.
Or unchangeable. We can say unchangeable. Like
Yeah, rigid
we
body.
have some moral values which are rigid. Right.
Yes.
It does not shape, does not change its shape, or it does not deform.
Yeah, does not deform.
Yeah.
So we can give a small explanation. There is no definition of anything, but just whatever we are writing, it's like a definition as an explanation only. We wrote force equals to mass into acceleration. We wrote velocity as displacement by time. We just gave an explanation. There is no definition of anything. Cannot be perfect definition for anything. That's what it's my way of thinking. Not necessary. Okay, let's see rigid body. A body which can be what? Like definite or unchangeable shape with a perfectly definite shape or unchangeable shape. Can you understand my handwriting?
Yes, sir.
I hope so. Because this is my best. I cannot make it better than this one.
No, sir, it's fine, sir.
Okay. If not, then I'll just type it and do it. That's only that way I can do.
You're fine, sir.
Everyone, right? All good? Yeah, one
Yeah.
more join. Yes, welcome to the class. Chanakya.
Good evening, sir.
Yes, good evening. So in
So this
short,
handwriting reminds me of my handwriting.
okay.
Yeah, mine was almost like this. Everyone hated my handwriting for no reason.
Everyone hated means it's not now. Is it like that?
Sorry, sir, I didn't get you.
It is like similar, same now, or it's a changed?
Same now, always has been, sir.
Then better change it.
I'll try it.
I always tell my student like, don't follow my footsteps. Okay. There's only two ways. Like you can make mistake and learn, or you can learn from others' mistake. I think you heard this from so many, right? So just one more time you learn it from me.
Yeah.
Okay.
Yeah.
Your voice broke. I don't know what you said.
Yeah.
Okay, nice singing. Okay, let's get back. So body which is perfectly definite or unchanging shape. That is rigid body. Okay, give me example of this. Okay, okay, wait. Let me write one more statement for that. Conditions. The distance should not be, or distance should be constant. Distance pairs of particles.
Example is a movie constant as long as it doesn't crash
Okay.
or it doesn't go like crazy speeds that fold the body,
Okay.
like 300 kilometers per hour.
Are you talking about supercars?
Yeah, exactly.
Not in Indian road, but
Yeah, not necessarily supercars. Some cars with seam welded bodies can do it too.
okay. Do not change. Okay, the distance between all pairs of particles of such body do not change. This is the condition. Now give me one proper example. Okay, one example from each. Yes, Mr. Varun. Mr. Varun. Knock, knock. Yeah.
Any like magnets things?
Magnets. But if you give discharge or discharge, it might change, right? Internal particles might change. Okay, no problem. That is also okay. It's a rigid body. As we
Yes.
talking about the rigid body, yeah, fine. Next, Divanshika. Knock, knock.
Yes, sir.
Yeah. She goes like, "Okay, yes, sir, I'm present." Okay. Yeah. Give me example of rigid body with this condition. Divanshika.
Sir, not have an idea, sir.
You haven't seen any rigid body around you. Where are you sitting right now?
So on the study table.
Exactly. That is the example. What I'm looking at, wall. That is the example. Yes. Then Ritvik.
Basically, a very strong body. So no matter how you try, it won't change its shape. Like
Which is a
a
strong
wall.
body? Yeah, wall. Yes, Sai. Knock, knock. Are you there?
Sir,
Yeah. Okay. Yes. Give me one example.
sir, would two planets be considered bodies?
You went too far. Yeah. That is also correct example. And Shrikar, what about your example? She went planet. And where do you want to go? Stars? Shrikar, yes.
First cars, then walls and chase. Now we're going stars.
Shrikar, yeah, your example? I'm sorry, I didn't get you. What did he say? Oh, something. Next. Water. Okay, mic is not working properly, sir. No problem.
Sir, is fire also is a rigid body?
Water cannot be rigid body. Fire cannot be rigid body. What about bridge? Yes, bridge is the best example. I gave answer and I'm only accepting. Nice. Yeah, wall, bridge. These are the best example for
Yeah.
rigid body.
Walls very rigid.
Yeah. Until we break it or apply some extra force, like
Yeah.
with so much
Enough
horsepower.
force needed. Yeah.
Okay. So distance between the particles. What does this statement means? Understand each statement because I'm going to write some conditions after that. So understand each statement. Distance between all the pairs of particles means if this is a solid, if I take the molecule of that, so they are tightly packed and their distance is unchangeable.
Yes, sir. The
Until
molecules
we-
will be very tightly packed.
Until we hammer it or like compress it or use hydraulic press and whatever you see in your YouTube channel.
Hydraulic press is enough, sir. There's not. I don't know nothing beyond it.
Yeah. I've seen that hydraulic press and they are like in that they were just pressing phone. Why?
More beyond that is crusher.
Yeah, and yes, they're crushing bikes. Oh my god.
Yeah. So much weird stuff.
Exactly. Okay. So enough chat. Let's go back to our topic. So distance between all pairs of particles of such bodies do not change. So clear with this?
Yes, sir.
So in short, that all axis, they're all particles are on fixed axis. Whatever axis we are taking on that object, they are fixed on that. Okay, so if I'm moving in this way, like this object, I'm moving this object, so this distance will be constant, but the object will be moving it with constant distance. This object will move with the constant distance. I'm moving the object, molecule will also move with that. So they are moving with the constant distance. Whatever it is fixed here, whatever we saw here, it is fixed, they are moving. I'm just saying same thing, just elaborating a little bit. We are moving, here it was steady, I'm just moving it now. With the particles or let's take particle. The particles are also moving with that, with a constant distance. So with that, let me write one more condition or a statement. In rotation of a rigid body about a fixed axis. Of the body moves. So we are moving a rotation. So all the body will move in what path? What is this path?
Rotational part.
Yes.
Circular path, circular.
Yes. Circular path or circle. That's right, circle. In a circle. Which lies in a plane. Which is perpendicular to this axis, whatever we are taking it. And in this axis only we have center. So that's what I'm just elaborating same thing whatever we are discussing here. center on axis. Now, this is the condition when we are just fixing one place. Let's take it as A, and we are rotating on this one. Now, if we are not fixing anything, not fixing, you understand, right? Like when you are you using a lap, if you are using a laptop, just you are fixing, like there is a hinge there. If you observe, there is a hinge there. Hinge on your laptop, when you're just opening your lap or whatever, you can say, what do we have, anything else? Yeah, even though.
Use, yeah. But yeah, hinge exists for screen.
I'm sorry?
Yes, sir. Hinge will exist in between screen and keyboard.
Yeah.
Sir. Yeah.
That is a pivot.
Yeah, my
It is
laptop
also
once had a problem like that, sir, and we had to get replaced the hinges.
Exactly. You have to go and replace the server set. Yeah.
Yeah.
Okay. So let's write point about that also. The motion of rigid body which is not hinged or pivoted. Or fixed in some way. Is either a pure translation. What do you mean by translation?
Changing one thing to another.
Changing one place to another. Or a combination of translation and rotation. Now this was rotation. Like in example, for example, I can say this is my inclined surface at some angle, whatever. Okay, I'm placing a ball here. So what will happen to the ball?
It will roll down, sir, due to gravity.
It will roll. Initially, it will start like position A. Okay, let me just draw it bigger. This position A will at this position, at this point, it will be A will be here. Then again, A will be here.
It will gradually increase its velocity, sir,
Yeah.
because of the deep slope.
Yes, that will be happening. Okay, but right now our point is this is what changing. So in short, what is happening here? It is rotating.
Yeah.
So this point is moving down and again moving up. In short, it's changing. So in short, it is rotating. Now, same thing, if I take a phone or a box, let's take a box. Okay, my box is very bad.
It stays fixed, it doesn't rotate.
So what will happen to the box?
It will not rotate, sir. It will
Slide
just
down.
go down. Yeah,
Yes,
slide
it
down.
will slide.
Slide.
Very good. So that is a translation. It is changing position. Point A, it translated from here to here. It moving in a straight path. Translation.
Yeah.
Do you remember you studied like a translatory motion?
Yes, I remember studying on past
Rotatory
classes.
motion also.
Yes. In
Translatory
translatory, we have
motion
two
and rotatory.
types. What is it? Can someone name? In translatory, we have two types. Can someone Do you remember? At least one, like some words.
Straight line motion. No, I don't remember, sir.
No? What about others? Varun, Devanshika, Sai?
Curvilinear motion
Yes, curvilinear motion.
and rectilinear motion.
Yes.
Just remember this.
Yeah, that's true. Curvilinear and rectilinear. And rectilinear. See, whatever you studied in lower standard, those are basic, very, very important. Yeah. So, what is curvilinear? What is like rectilinear? Rectilinear propagation of light. Do you remember this word? Only two members are saying like, what about other three? Yeah, the third one, like, mic is not working. Fine. What about you two girls?
I'm just listening, sir.
Okay. Okay. So rectilinear means moving in a straight path, or as I said, rectilinear propagation of light means light travels in a
In a
straight
straight line.
path. Yeah, straight line.
Curvilinear means it's moving in a curved
Curved path.
path. Yes, sir.
This is straight path. But translatory means movement. From here to here it moved. From here to here it moved. That is translation. Okay, so here in this one it was rotation, and this one it was translation. Now it can be possible like a rotation without translation. Is it possible? Rotation without translation.
No, sir.
Can it be possible? Think and answer yes.
No, it's not possible.
Not possible?
It has to change placed on the sir. So we need translation.
Okay. Actually, it can be possible. It can be rotation, like when you are playing with a spinning top, you know, spinning top, right?
Yes.
It is rotating in its own position, in its own axis.
Yeah.
Oops, I clicked on wrong place.
Yes, I used to play with tops when I was a small kid.
Oh yeah,
I still have them around, sir, today.
spinning top.
Yeah.
Okay. So yeah, so it is possible rotation without translation, but is it possible translation without rotation in reverse order?
No, sir.
Why not? Just now we saw it is not rotating and it's translating.
Possible.
Right? It's possible, no?
Yes, sir. In short,
Yeah.
need to rotate always.
Okay. Okay, so let's continue out. I'll erase all this. I didn't finish this point actually. Okay, then I'll make a new point. So the motion of a rigid body which is pivoted somewhere in some way is rotation. This is the rotation. Some way or other way, it is called rotation. Like when you are opening your door, just if you're confused, just put your pencil with your door and open it and close it. You'll get some semicircle or part of a circle. Segment, I think so. It's called segment, no? In mathematics. This portion is a segment, no? I guess so. Okay. Can you all hear me, right?
Yes, sir.
Okay. You're not saying something, so I thought, okay. Fine. Now, let's go with the chapter now. We saw some basic idea about this rigid body and all. Let's see. All rigid body have center of
mass.
mass and center of gravity. So now, what is center of mass?
Where the whole mass is concentrated in the body.
Exactly. So if I take like this object, so where will be center of mass?
In the center.
In center, where can we say I can where I can say it is a center? This point is a center. Geometrical center, I can say, right?
Sir.
Geometrical center.
Yeah.
Draw two lines or
Like diagonally, right?
Yeah. And where
But
the body
your-
intersect, that's the center.
At this point, I can say center of mass.
mass.
But will it be same for center of gravity?
No, sir.
No, sir.
Now it depends. It depends upon
Depends
orientation.
upon the body, sir.
Yes, it depends upon orientation of the object or whatever body it is. So center of mass and center of gravity can be same at, can be at the same point, cannot be
But-
same,
yes, sir.
cannot be as a same point.
Yeah, only gravity acts, sir. It's on, but mass is concentrated.
Yes. True. So, and is there any point like we just now I drew this one? Is there exactly any point here? Can you, if you're holding your phone for a class and there is a center point, is there even mark there? No, this is called center. There is no mark there, right? But we have like draws these lines and we just got it. Okay, this is the center point. That's why this is an imaginary point. This is an imaginary point.
The best example is door handle. Also.
Yeah, door handle, right? What do you say?
Door
Can we-
handle, sir. In center.
Okay, yeah. It's imaginary point where the whole mass concentrated. Can be concentrated. Or this is an assumption. Is assumed. Like everything is what 99.9% is, right? Even that all cannot clean 100%. I know it's a bad joke, at least you can laugh, huh?
Can you repeat the joke?
Acha, all muted, right? What is this?
Okay, never mind.
Okay. Okay, let me draw a line. Okay. This O center. Now two masses. M1, M2. This is the distance X. X1, X2. Now what are this? Let's write that. The center of mass two bodies lies in a straight line. Straight line. So what are two bodies? M1 and M2. So M1 and M2 are two bodies. So M1 is the distance from X1 from center O, and M2 is at the distance X2. M1 is at a distance X1. M2 is at a distance X2 from O. So midpoint, that is X. Let me write this as a capital. Okay. You know this, right? X equals to, yeah?
Equals to mx1,
Yes.
m1x1, m1x1 plus m1, m2x2.
I'm sorry, X1 plus M2 X2
by m1 plus m2.
Yes. Or we can add one more term if it is one more particle. M1 x1 plus M2 x2 by M1 plus M2. So this is I drew for 2 dimension. If it is for 3 dimension, it will be x, y, z. Similar with third term.
Sir,
Yes. Are you all hungry or what?
no, sir.
No, sir.
Oh yes, sir. I got yes.
Good.
Because I'm getting just 2 answers. Like 2 people are speaking, just Varun and Ritwik.
I said no one, sir.
I also said no, sir.
Acha. Okay. What about remaining 3?
No, sir.
Oh, she's
No,
present.
sir.
Oh, she's also present. Very good. And yes, Mr. Muted guy. Oh, yeah, okay. We can type. Okay. Then if it is 3 dimension, let's write about 3 dimension. Coordinates of center of mass of body will be x, y, z. Okay, let's make it as capital. There's nothing difference, but x1, x2, and we'll take as a point. Subpoints. So x equals to summation of mi
Mi plus N.
xi divided by capital M. What is capital M? Sum of all mi. But what is mi? Mass of ith
So
particle.
Yeah.
Then what is I?
I is a particle.
It's a point.
I is the point. Okay. Mi, yi,
Y,
Hey, Kaplan.
capital M.
z summation of.
MIZI
Mi Z I
by Kaplan.
capital M.
Now where or whatever, where, here, whatever you want to write. Capital M is sum of all mi.
All my
Mi is
mass
mass of
I particle.
ith particle. And what is I?
Particle.
I is a number from 1 to n.
And
Now again we got n, new term. What is n now? N is a natural number. There is nothing new here.
Yeah.
So in short, what we are doing here, we are making the sum of all m1, m2, m3, and blah, 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 whatever we have here. Here we have 2. In this equation, we had 2. If it is nth term, it will go till nth, mi, xi by
xi by
mi,
M.
whatever it is. So it's for ith particle. I is the 1 to n numbers. Now, position of I is given by these people, whatever we wrote here. We started from where we started x, y, z. So position of I, position of I is given by xi, yi, and zi. So we saw x, y, and I. So x is here, all this term, y here, z is here. So we have all these three directions, right? So there will be like a point for this one, and height will be here. So there will be a somewhat point here of this each point. Like if I'm taking this point, it will be here somewhere. Let it be whatever number. Okay, so this point is x, y, z direction. So there, for that, there will be a resultant also. So just now I drew this one. There will be a resultant for this one. That is what we are going to find out. So resultant R, which is in vector form, x I cap plus y I cap plus z I cap. These all are in ith. The same way what we wrote here, sum of all this R. Instead of like x here, same way we'll take here for sum of all. 1, it will be 1, then 2, then 2, 3, then till ith. So summation of mi ri by m. So by this we can say it is what distributed in this small term. So we can say rigid body can be treated as continuous distribution. Distribution of mass. What happened? Someone is joining and leaving. Internet issue. Okay. Yeah, that happens.
Okay, sir, let's continue, sir.
Yeah. Okay, fine. So if we have, just now we saw these things. We can make it sum directly like this. Okay, we can add it. Okay, fine. We can have, if we have something, let's take example. Yeah, let's take stairs. And let's take a slope. Here, we can just count as like 1, 2, 3. We can count this way, 1, 2, 3. And if we want to find area, we can just directly find here, okay, whatever length into breadth. If we have length into breadth and length to breadth, we can add all this 3, 1 to 3. But here there is no fixed way. This is, okay, if we know the formula, okay, triangle, it's triangle, okay, we can find out, fine. But if it's not exactly a triangle or some other shape, which we don't know formula or anything like that, so what we do, we generally integrate this, integration. You have studied in the first class of your 11th standard, right? Integration. Do you remember the first class of your integration? You know, right? Basic of integrations. Was yes or no?
No, sir.
No, you haven't studied? Okay. No problem. With this chapter, like I think so you're used in work power energy also. Integrating work. Oh yeah, you didn't finish chapter, yeah? Okay, fine. Fine, no
That's
problem.
already the beginning part of work power energy.
Okay. No problem. Then I'll teach you some of it. As we do it, I'll teach you that. Okay. Integration means, in simple, like I'm not going in mathematics, it's simple terms, just add it. Okay, we can add here simply like 1 plus area of 1 plus 2 plus 3 area here, because they are like literally we know like it's L into B, L into B, L into B. Here we cannot find out, we cannot make it like something here. It's like ramp. Okay, it's a stairs here. So what we'll do, we'll integrate. We'll take a strip of this one. We'll find area of this strip, and we will integrate with, because it is same area here also. If we take here also, it's same. If we take here, it is also same. Okay, so what we'll do, we'll find out integration of this, sorry, do area of this one, and we'll put the limit of this one. It's varying from here to here, 1 to 2. We'll do integration of this strip dx, whatever, into L dx. Okay, and we'll integrate with 1 to 2. Limit is 1 to 2 in continuous distribution. It is even this is the easiest way to solve this. If you for solving any numerical, integration is the easiest way to solve any type of thing, any type of shape, or finding area of, or finding like area of those things which cannot find by formula, which is easiest way. So let's see the integration part. So what formula we wrote here? No, previous one. So x equals to summation of change in mi xi by summation of all mi. That is capital M we wrote here, right? Same way for y. Summation of mi yi by summation of change in mi. We cannot make it cancelling here, okay, because it's in summation multiplication here. So this in summation we are going to change as integration. Summation of delta mi, which is integration of dm. Now, for this rule, let me tell you first rule of this one. Then as we are doing it, I'll tell you another rules also. There are some rules for this one, integration. So make a note of this one also. Integration of dx, or let's mean x dx. So formula is x to power n by n plus 1. So here if it is 1, so it will be x to power 2 by, sorry, x to power 1 plus 1 by 1 plus 1. I wrote directly actually. Hmm. 1 plus 1. So it will be x to power 2 by 2. You got the first form? Any doubt in this one?
No.
No, you can tell me straight away now itself. Whenever we are doing something, you can stop me there. No, sir, I didn't understood. It's better way.
Sir, can you repeat once again?
Okay. Now see, what is it? Integration of x dx. So we are integrating x with respect to dx. This is the integral term. What we are integrating? X we are integrating. Okay. So let me take another example. Y dy. So what you will do here? What you will get? I'm integrating y with respect to dy.
Y raised to n plus 1 by n plus 1.
Exactly. So what you will get? Next. What's the next step? Just tell me final answer.
Y squared by 2.
Yes. It will be y squared by 2. Now, what if I'm just saying integration of dx? What do you mean by this one? Why you took 1 here?
Integration of 1.
No, yeah, n is 1 here, right? That's what.
Yes.
But how you got n as 1?
So since beside of dx there is nothing, so
Not, yeah, on the as a power of x is 1 here. And anything to the power 1 is 2, right?
yes, sir.
Now anything to the power 0 is
1.
1. So this means integration of x to power 0 dx. Is it meaning same?
Yes, sir.
Are these two same? Okay. So integrate this one. Integration of x to power 0 dx. What you will get? Think.
X only, sir.
Yes.
X
Obviously.
only.
Yes. Because x to power 0 plus 1 by 0 plus 1, which is x to power 1 by 1, which is x. Exactly. As we have solved once, so I think so you will remember now. No need to solve this thing again and again, right? By seeing only you will get answer. That's why I ask you to solve. Because we will use this again and again. Understood this one, everyone?
Yes, sir.
Yes, sir.
Okay. 2. What about Varun?
Yes, sir.
Okay. What about Sai?
Yes, sir.
Sai, are you sleepy?
No, sir.
Okay. Your voice is like that.
No, sir. I'm fine.
Just joking. Yeah, fine. So, okay. So let me, oh, not me, you will tell me answer. What? Okay, let's come back to our this question. Integration of dm. What would be integration of dm? We'll say answer. Yes, Sai. Tell me. You will answer this. Integration of dm. It's okay, but it's wrong. I'm not gonna judge you.
Sir, I'm not sure.
Not sure. Yeah, what is it? It doesn't matter. Like at least something, some input. Call a math student here.
So I think all are max students only.
Okay, and just maths or biomath, both.
So only math students only there, sir.
Sure. Okay, okay. Fine. Okay, so integration of dm will be
M.
exactly. Again, in mi xi integration of x dm, then summation of mi yi integration of y
IDM
YDM.
dm.
of
Then what left?
my Z.
Yeah, z. Yeah.
That's MI equal to integration of ZDM.
Yes. Okay. So here we got almost everything. Are we missing anything? Mr. X, Mr. Y, and Mr. Z. All three came, right?
Yeah. All gentlemen came.
Gentlemen. Okay. This much we did for just one thing, that is center of mass. We are finding coordinates of center of mass. Center of mass, coordinates. Wait, need. So for x, 1 by m integration of x dm. Why m is not good, is so fat. Why? Same.
Integration of YDM.
YDM.
Hey, I guess you all like derivations. You don't like theory. That is what my assumption, right? Yeah? Am I correct or not correct?
Yes, sir.
I'm done with derivatives also.
No. why I assumed this, because when I was asking like some theory question, like it was so silent.
Sir, definitions are better than this.
How definitions
If
are
you
better.
practice enough, you'll get it. It's not that technically it's not difficult chapter.
Oh,
It's a
Differentiation.
no, like it's annoying to keep doing the same thing again.
Yeah, you're right. But this is math. What do you
yeah, what do you expect? Correct.
expect is math, right? After all.
Okay. Yeah, before you go into heated argument. Yeah. So R is what? Positional vector. R is positional vector. Means position. Now, small r, that is small particle, each particle. This r is position vector of each particle. Position vector of, this is positional vector, and this is position vector of each particle, small r. Is it clear, right? R and capital R and small r. Is there any confusion here? Is there any confusion till now?
No, sir.
Sir, no,
Okay. So do you have any class after this?
sir.
Also,
No?
No.
Acha. Okay then. Tomorrow we'll continue with, not tomorrow, I think day after tomorrow, we'll study with homogeneous body and remaining thing.
Yes, sir.
Okay.
You all guys had fun, right?
Yeah.
So you
Class more
Yes.
introvert. Well, guys, that's fun. Okay. Fine. Good, good. It's okay. It can be a class representative also. Okay, can you send the recording? I have joined it late. Yeah. Even that time I didn't start a recording also. I started late.
So you send the recording in Google Classroom.
Yeah.
Okay.
As usual, how they are making it.
Yeah, it'll be helpful, the recordings.
Sure. Okay. See you tomorrow. No, day after tomorrow. Till then.
Yes, sir.
Thank
Bye-bye.
you, sir.
Thank you, sir.
Thank you, sir.
Have a nice day, guys.
Thank you, sir. Bye.
Bye. Have your nice dinner.